You know that feeling, right? You write a script, it works, you're a hero. But then you come back a month later and you have absolutely no idea what you were thinking. Yeah, we've all been there. Today, we're going to fix that for good. We're going on a journey to transform those confusing scripts into clean, professional, and honestly, beautiful Python code.
I mean, does this look familiar? We all start out just throwing related data into lists. And for a minute it works, but it gets messy, fast. What does index 1 mean again? Is it age? Year? And look at McCoy's data. The age is just gone. The whole structure is broken. This is a one-way ticket to bugs, and trust me, there is a much, much better way.
So how do we level up from those messy lists? Well, here's our roadmap. We'll start by digging into the problem a bit more, then introduce classes as our first big solution. From there, we'll build on that with inheritance, uncover some of Python's awesome magic power tools, and then wrap it all up by showing you why this will make you a way more effective programmer.
Okay, so we've all agreed simple lists are fragile. They're hard to read, a pain to maintain, and super easy to break. Now, let's talk about the solution. So how do we fix this chaos? We need a smarter way to bundle our data together. And this brings us to a huge idea in programming: object-oriented programming. Now, don't let that fancy name scare you off. It really just boils down to creating blueprints for our data. The very heart of this is the class, and the best way to think about a class is like a blueprint for a house. The blueprint itself isn't a house, right? You can't live in it, but it's the detailed plan you use to build one, or 100 identical houses.
And this slide right here perfectly captures the difference between a class and what we call an instance. The class is the blueprint, the blank form. The instance is the actual thing you build from it, the form filled out with real information. So class dog is our general template for any dog. But Miles, well, Miles is a real specific dog with a name and an age.
And you know what? Building your first class is actually pretty straightforward. It's really just 3 steps. First, you define the blueprint with the class keyword. Second, you create the special __init___ method. That's the function that runs every time you create a new object. And third, you use that self keyword to attach the data, like name and age, directly to the object you're creating.
Okay, so we've got our blueprints, but what if we want to create a more specialized version of something? We definitely don't want to copy and paste our code and start from scratch. That's where inheritance comes into play. It's all about building on the work you've already done.
Let's say our general dog class has a speak method. It's a decent start, but it's pretty generic. Every single time we use it, we have to tell the dog exactly what sound to make.
Now this is where inheritance starts to get really powerful. We can create a new, more specific class called Jack Russell Terrier that inherits everything from our dog class. Then we can give it its own customized speak method that has a default sound. So now, any Jack Russell we create will arf by default. How great is that?
Uh-oh, but hang on a second. There is a trap here. What if we go back and improve our original dog class to say barks instead of says? Our Jack Russell Terrier class won't get that update because we completely replaced its speak method. We've disconnected it from the parent. The solution is an amazing little function called super. Instead of completely replacing the parent's method, we use super to call the parent's method from inside our child method. This lets us keep all the goodness from the parent, including future updates, while still adding our own custom logic. We're extending, not replacing.
All right, let's shift gears. We're about to dive into some of Python's more, let's say, magical features. These are the tools that really make Python so expressive and fun to use once you get the hang of them.
Ever seen that little @ symbol sitting on top of a function and wondered what it is? That's a decorator. Think of it as a way to wrap a function with extra powers. For instance, you could use a decorator to automatically time how long a function takes to run, all without changing a single line of code inside the function itself.
So what's really going on behind the scenes? Well, the magic is actually just a clever bit of syntax. That @ symbol is just a neat and tidy shortcut for taking your function func and passing it into another function depreciated to get a modified version back. It's just a cleaner way to write it. Next up, the with statement. Come on, admit it. You've probably opened a file before and then completely forgotten to close it. We all have. It happens, but it can cause major issues. The with statement is your safety net. It guarantees that things get cleaned up properly, like closing a file, no matter what happens. And what the with statement saves you from is writing this, a try finally block. This structure is designed to guarantee that the finally part always runs, even if an error happens in the try part.
The with statement just gives us a much more readable and elegant way to achieve the exact same thing. So really, think of context managers as your code's safety net. Even if your program hits a snag and crashes right in the middle of doing something, the with statement makes sure that cleanup code still runs. It's a simple trick that makes your code way more robust and reliable.
And finally, we have generators. Imagine you need to process a text file that's like a gigabyte in size. You can't just load that whole thing into memory. That's where generators are a lifesaver. They use the yield keyword to produce values one at a time, on demand, so you can work with massive datasets using barely any memory at all.
Whew, okay. We have covered a ton of ground, from basic classes all the way to some pretty advanced Python features. So let's just take a breath and talk about the big picture. Why does any of this actually matter for your day-to-day coding?
Look, at the end of the day, it all comes down to these four things. We want our code to be reusable, so we're not constantly reinventing the wheel. We want it to be maintainable, so we can fix bugs without headaches. We want it to be readable, because code is read far more often than it's written. And we want it to be robust, to handle errors gracefully. These tools get you there. So there you have it. You've seen the blueprints for structuring your data and the power tools for making your code safer and more elegant. The only question left is, what amazing thing are you going to build next? Thanks so much for watching, and happy coding!